Hey students, this is Mrs. Tran-bloom. I am recording Algebra 2 notes, and this recording is for graphing radical functions. So we are going to start with the first graph, the first parent graph. The name of this is called a square root function, and the equation is y equals square root of x. Let me get a highlighter. Okay. So we call this the square root, and y equals square root of x. As you know by now, we can have different and multiple different roots. So we can have square root, which is normally we do not write the 2 in that little vertex there. We can have cube root, we have fourth, and so on and so on. Now the HK form, HK is, we normally call it the vertex if we are talking about the parabolas, right? So let's remind ourselves really quickly. If we have the parabola, we had y equals a times the quantity x minus h squared and then plus k. So the h and k will be the vertex. Then we also study, let's see, what else do we study? Cubic, okay. We study the cubic, so y equals a times x minus h to the third plus k. So that was the h and the k was the inflection point, okay? So h and the k were the inflection point. Then we also study absolute value. So let's go. Absolute value functions, okay? We had y equals a times the absolute value x minus h plus k, where h and k were also the vertex. Then we also had lines, right? We studied line. And the line we studied was in the points of form. We had this, right? It's the slope times x minus h. That was the points of form. X minus, I should say x1, if that's what you're used to. But technically, if I move this y1 over here, wouldn't you agree that's the same thing as y equals the slope times x minus x1 and then plus y1? Well, isn't that very similar to this format? Would you agree with that? Where the h and the k, so technically I can rewrite this as a different color. Y equals a times x minus h plus k, right? So the x1 and y1, they are the same as the h and the k. So the points of form in the line, it's almost identical to the HK format of all the functions we've studied so far. So this one is the square root function. So the parent function would be, we will start with the x and y, and we will start with the 0 because in the square root, we can't have negative numbers under the radical. So the smallest number you can have is 0. So 0, and I'm going to pick 1 because that's the first nice square number. And then 4 is the next nice square number. I'm going to pick 9, and I normally want 5 values altogether. So we're going to go all the way to 16. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Remember, this is square root of 4, so that's really 2. Square root of 9 is 3, and square root of 16 is going to be 4. So we are going to plot this out to see what that looks like. 0 and 0 is right here. 1 is 2. Whoops. X is 9, y is 3, and technically I can extend this out a little bit all the way to eyeball 16, and when x is 16, y is going to be 4. So this is what a square root function looks like. It's sort of like a half parabola, a half sideways parabola. So if I want to go further, I could draw this from the bottom, and later we're going to see why we have a radical or square root function, okay? So here is our square root function. It looks like an eyebrow curve, and oftentimes I refer to an eyebrow curve because it looks like one eyebrow curve. So the h and the k form, the h and the k values would be 0, 0. For this one, you don't have any axes of symmetry. So if I fold the left and the right won't be anything the same. If I fold it horizontally, up and down won't be the same. So there's no axes of symmetry, unlike a parabola. So I'm going to write none if it, there you go, and none. Excuse me. Excuse me. Okay, so the x-intercept for the parent is at the origin, so we call it 0, 0. And the y-intercept for the parent will also be at the same spot, which is also 0, 0. The domain, as you can see, the domain is all values of x. And we can say x is bigger than or equal to 0. Or we can also write it in the interval notation, which is inclusive from 0 all the way to infinity. Once it's not frozen on me, I would, okay, so I'm not pinch it in. It doesn't like it when I pinch out too much. The range, as you can see, the same thing, right? We can say, okay, well, y must be bigger than equal to 0. Or we can say y value, since it's interval notation, the smallest y value we can have is 0. And it goes upward forever towards infinity. So y and x, domain and range in the parent function of the square root, they are exactly the same. As you can see, this is always increasing. So it's increasing from 0 all the way to infinity. And that means it's not decreasing ever. So decreasing doesn't apply. So it's increasing the entire domain for the square root. The rate of change will varies. It is definitely a 1-to-1, and it has a minimum value of 0. That means the y value. What's the lowest value? 0 at x equals to 0. And it does not have a maximum value because it goes up forever and ever. It doesn't have a horizontal asymptote or a vertical asymptote. So all of those are non-applicable. So that's pretty much the parent function of the square root. So let's recall the transformations again. If your value of a is negative, this is a reflection. Reflect over x-axis. If the value of a, if the absolute value of a is less than 1, so let's say it's a 1/2, a 3/4, then it's a vertical compression factor of whatever that is, okay? Whatever that a value is. Now, if the a value is 2, 3, 4, 2.9, 1.11, then that means it's a vertical stretch factor of whatever that a value is. H is a translation to the left or right. So translate left if H, okay, left or right, okay. Left if H is negative, okay, H is negative, so H is less than 0. Right if H is positive, which is bigger than 0. K is translation up or down. Oops. Translation up or down. Now up if K is bigger than 0, that means it's positive, and down if K is negative, which is less than 0. So these are the guidelines to graph any function in HK form. First, you have to identify the parent function. Since we have so many now, we have studied so many, you have to figure out what parent function goes with the equation. Then next, make a table of values for your parent function. What x value makes sense to plug into this function? Identify your k, your h, and the a value. Those will tell you, okay, do you need to stretch or compress? Do you need to reflect or not? Are you going to go right or left, which is the h, and are you going to go up or down, and that's your k? Then most of the time, you're going to ask to list out the transformation. then make a new value, right? This is the parent. Then you want to translate it accordingly. The A and the K will always, always, always change the Y, all of the range. The H will always, always, always change all of your domain. And then just plot your new points. All right, so let's try example 2 and 3 sets. Graph each function, then find all defining characteristics. So first, A value is going to be 3, X plus 6. So that means H is really a negative 6, K is a negative 4. Negative 4. So that means I can write my H and K right away. Negative 6 and a negative 4. First is I want to write in my parent function. So parent, you have to identify the right parent. Y equals square root of X. That will allow me to make the right table. Remember, if it's a square root, I cannot have negative numbers under the radical. So I had to pick all positive values and try to pick nice positive values, okay? Okay, so square root of 0, 0, oops, square root of 0, 0, square root of 1 is 1, 3, and 4. Okay, there you go. So with that, you can use the A, H, and K to transform. The 3 will change my Y. It's a vertical stretch, so I'm going to straight that down here. Vertical stretch factor of 3. The H is going to transform my X's. I will now, oops, minus 6, right? So what that means is left 6 units because H is negative. Then your K is negative 4. So now that tells me my graph should move downward 4 units. With that, I can now use my parent, which is in red, and then translate the A, H, and K. 0 minus 6 is negative 6. 1 minus 6 is now negative 5. 4 minus 6 is going to be negative 2. 9 minus 6 is positive 3. And 16 minus 6 is a positive 10. Whoops. All right. Now, 0 times 3, I'm transforming the y's now. There you go. Oh. 0 times 3 is going to be 0. Minus 4 is going to be negative 4. It's frozen on me, so let's see if it stopped. There you go. Okay. 1 times 3 is 3. 3 minus 1, 3 minus 4 is going to be negative 1. 2 times 3 is 6. 6 minus 4 is 2. 3 times 3 is 9. 9 minus 4 is going to be 5. And 4 times 3 is 12. 12 minus 4 is going to be 8. So those are my new values that I will now try to plot. Okay. It doesn't like it very much when I zoom out too much. So I'm going to be careful with this one. So my first point is negative 6 and then negative 4. Okay, remember, this starting point used to be 0, 0, so it should really match your H and K value, okay? We moved left 6 unit and we went down 4, so that should match up. Negative 5 is now negative 1. Negative 2 is now positive 2. Positive 3 up to 4, 5. And 10 goes up to 8. Mind you that, remember, we also had a vertical stretch by 3. So what that means is not only that we move left and we move downward, the y values got bigger by 3 times. Okay. Okay, do we have any x in this set? Yes, we do. And I can't really eyeball that, so I'm going to work that out down here. X-intercept is when y equals to 0. So we will take the equation, plug 0 in for y, and try to solve for x manually. So to solve for x, remember, oops, this is x plus 6. minus 4. Remember, we have to isolate the radical. So first add 4 to both sides. So this will give us a positive 4 on the left side. Next, we want to divide both sides by 3. So that's going to give us 4 divided by 3. Next, we are now going to undo the radical by squaring both sides. I'm out of space, so I'll move down here. That's going to be 16 over 9 plus, equals x plus 3. Subtract 3 from both sides. I have to find a common denominator, so 16 over 9 minus subtracting 3, the denominator is 9. That means I need to multiply this by 9. That's now a 27, okay? So 27 divided by 9 is going to be negative 3 equals x. Try to simplify that out. 16 minus 27 is going to be a negative 11 over 9, which is our x value. So that's the x-intercept. Remember, it looks like, if you look at the graph, it looks like it's about negative 4. But I knew that's not going to be okay to eyeball that. So make sure we always try to solve it algebraically. So x-intercept is going to be negative 11 over 9, comma 0. Yes, you can also give it to me in mixed number, negative 1 and 2/9, comma 0. Either one is fine. Y-intercept again, I want to eyeball that, but you can't really do that, so make sure you solve that. Y-intercept is when x equals to 0. So I'll do the work down here. Y int, x has to be 0. So that means y equals 3 times square root of 0 plus 6, all under the rad, minus 4. Well, I can't really do anything about radical 6 without a calculator. So technically, you can leave it like that. So I'm going to write 0, comma 3 rad 6 minus 4. If you have a calculator, you can feel free to punch in radical 6, multiply by 3, and subtract 4. I will, but most likely just keep it in radical if you don't have one. No big deal, okay? The domain is going to be from the graph and from your table. The domain is going to be x is bigger than or equal to negative 6. Or you can say, okay, it's from negative 6 inclusive all the way to infinity. The range looks like it's going to be y is bigger than or equal to negative 4. Or you can say from negative 4 all the way to infinity, including negative 4. It is an increasing interval, so that means decreasing is non-applicable. It's increasing from the entire domain, so it's negative 6 all the way to infinity. The rate of change varies. It is definitely 1-to-1. It does not have a maximum because it goes up forever, but it does have a minimum. The minimum value is the y value, which is negative 4 at x equals to negative 6. And that's the same thing. Now, as all of the other functions, the only thing now, it looks like more of an eyebrow curve versus a V or a parabola or a lazy S curve or a straight line. So it now looks like one eyebrow curve. Let's do one more. This one is f of x equals negative square root of x minus 4 plus 9. And again, we want to start with the parent function. So if you practice writing the parent, what it is, then later it will just stays in your brain longer. So we will start with the parent function value. Again, we can't have negative number under the radical, so we will start with 0 and 1 and 4 and 9 and 16. Why do we pick those? Those are perfect square numbers. So the square root of 0 is 0, square root of 1 is 1. This is 2, 3, and 4. I'm going to get a different color pen to graph this one. How about let's see. How about purple? Sounds good? Okay, let's try purple. You have an a value of a negative 1, and you have an h value of 4 and k value of 9. So because a is negative 1 is negative 1 times y, and we're adding 9 because that's your k value. H is 4, so we are going to shift right 4 units. We might as well spell out the transformations. Ready? reflect over x-axis, and h is positive 4, so right 4 units. K is positive 9, so up 9 units. All right, so let's use the parent values from the table and then add 4 for all the x's. So 0 plus 4 is 4, 1 plus 4 is going to be 5, 4 plus 4 is 8, 9 plus 4 is 13, 16 plus 4, it's going to give me 20. And it looks like it's frozen. Oh, there you go. 8, and I meant to write 13 right there if it's going to come up at all. And then 16 plus 4 again is 20. There you go. Okay, I'm going to unstretch it because like I said, it doesn't like it when I stretch too much. So hopefully that will help out. Take all the y values from the parent and transform. 0 times negative 1 is 0, plus 9 is 9. 1 times negative 1 is negative 1, plus now is 8. 2 times negative 1 is negative 2, plus 9 is positive 7. 3 times negative 1 is going to be negative 3, plus 9 is going to be 6. 4 times negative 1 is negative 4, plus 9 is going to be 5. Okay, so let's see. 4, 2, and 4. Let's see if I stretch it. It's going to be mad at me or not. Okay, 4, I'm going to go straight to 9. Okay, 5, I am now go to 8. And 8, I'm going to 7. I'm waiting to see if the dot's going to show. There you go. 13, I'm going to go a little bit to the right of the grid. Just go down to 6. An eyeball right there. And I don't have 20 boxes, 20 tick marks. So I'm just going to eyeball that over here. Okay, so I'm going to pretend this is 20. And you don't have to graph this last dot if you don't have enough space. But I'm just trying to plot it out so you can see what this looks like. So if you can see, this is an upside down eyebrow curve. And these are my 5 dots right there. Okay. All right, H and K. Immediately we can fill that in. That's 4, 9, no big deal at all. X-intercept, eventually it's going to hit the x-axis, even though right now we can't see it. So we have to solve for it algebraically. X-intercept is when y goes to 0. So 0 equals negative square root x minus 4 plus 9. So the first thing we want to do is move the 9 over. Okay, so negative 9 equals negative x, radical x minus 4. And then divide both sides by negative 1. So positive 9 equals square root of x minus 4. Now you square both sides. There you go. Square both sides. Anytime it's kind of freezing on me, I'm just going to wait for it to come up. Like now it's freezing on me. So let's see if it's going to come up anytime soon. There you go. 9 squared, it's 81, equals radical and square will undo each other. So what you have is you're going to have x minus 4 on its own. Add 4 to both sides. X is going to intersect at 85, and that's why it's not showing up on our graph. So 85, 0. Y-intercept, as you can see, it's going to go downward and to the right. So what that means is that's never, ever going to intersect the y-axis. So we can straight up write non-applicable. The domain, it looks like the x value is starting at 4. So we can say x is bigger than 4. Or we can use interval notation from 4 all the way to whoa. Oh, that was weird. From 4 all the way to infinity, if I can get it back to where it was before. There you go. So 4 to infinity. The range value, as you can see, the highest y value we have is 9, and it keeps going downward. So what that means is y is less than or equal to 9, or we can say negative infinity all the way to positive 9. It is not an increasing interval. In fact, it is a decreasing interval from 4 to infinity, which is the same as the domain. The rate of change is going to vary. It is definitely a one-to-one. It does not have a minimum this time. It has a maximum value of a y value of 9 at x equals to 4. Okay, so that's the decrease function of the radical, which is the square root function. Now, if we look ahead really quickly, the next video will be cube root. And this is where we are stopping for today.